Hello. We are going to focus on looking at dilations and graphing the image. So before we determine finding the scale factor of an image, whether it was a reduction or an enlargement, now we're going to take what we know about dilations and we're actually going to take the points that we have and we're going to graph the image once we've enlarged it or reduced it. Couple things to remember is if we have a whole number, if we are dilating an image, a pre-image by a whole number, that means we're going to make it bigger. And if we're dilating a pre-image by a fraction, that means it's going to be a reduction and it's going to make it smaller. So let's take a look at an example of this. So we have this triangle here and we want to graph this triangle after a dilation with a scale factor of 3, which is centered around the origin. So we know that our scale factor is going to be 3. And then what we want to do is we want to look at each one of these points. Okay, so we have K, L, and M. And so we'll start with K here. K, if we start at the origin at 0, we're going to go 1 to -3 places on the x-axis, but then we're not going up or down. We're not going any place, any movements on the y-axis. And then we look at L, and L is, we go -3 places on the x-axis, but then we're going to go up 1 to 3 places on the y. So this is going to be at -3 and then +3. And then M is going to be, instead of going left on the x-axis, we're actually going right. We're going in the positive direction 2 places. And then we're going down -2 places. So we have all of our ordered pairs, all of our coordinates listed out now. And so with that scale factor, what we want to do is we want to multiply each one of these coordinates by 3. And so we would say -3 times 3, 0 times 3, that's going to give us the image of K, which would be -3 times a +3 would be a -9. Remember, same signs positive, different signs negative. And then 0 times 3 is just going to give us an answer of 0. So that's our ordered pair for K. Then over here for L, we're going to do the same thing, -3 times 3, and then 3 times 3. This would give us -3 times a +3 is going to give us a -9. And then 3 times 3 is going to give us a 9. And then for M, we're going to do the same thing. We're going to have 2 times 3, and then -2 times 3. And this would give us 2 times 3 is 6, and then -2 times a +3. The signs are different, so this would be a -6. So once we have all of our ordered pairs for our image, once we have completed that scale factor, then we can go back through and we can graph them. So let's start with K. And I'm going to go ahead and erase all this because this is our pre-image. So K is at -9 and then 0. So we're going to start at the origin. We're going to move to -9 on the x-axis, and then we're not going up or down. So this is going to be K, and we have graphed that one. The next one that we have is at L, which is at -9, and then we're going to go up to 9 here, which is L. So we've graphed that one. And then M is going to be at a +6. So we're going to the right 6, and then we're going down to -6, and that would be M. And then once we have all of these points, we can connect these. And we can see that the shape is still the same. We still have this triangle, but it is much larger than what we started with our pre-image because we dilated all of the sides by 3. We multiplied all of the sides by 3. And that's another way we could look at it too, is we could say, okay, from the pre-image, This was 1, 2, 3. The length of this side was 3. And so if we multiply that by 3, we know that this longer side of L and K should be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's a good way to check your answer too. The only thing is like with K, M, it's not really, we can't really check that answer because that would be, we would need to find the slope of this line and then find the slope of the other line. You could check it, but a good way is to just make sure one of the sides is a scale factor by 3. So let's look at another example here. So what happens, we saw an example of an enlargement where we multiply by a whole number, but what happens when we have a fraction? So in this case, we have a square, it's CDEF, after a dilation with a scale factor of 1/2 that is centered around the origin. So we need to do the same thing that we did before. We need to have all of our ordered pairs, so C, D, E, F, and we need to first list those ordered pairs. So I'm going to start with C here. So C, we start at the origin. We're going left to -10 on the x-axis. And then we're going from -10 down to -6 on the y. So this is our coordinate for the point C of our pre-image. Next, we're going to look at D. And this time we're starting at the origin. We're going +6. And then we're going down -6. Then we're going to go to E here. And E, we're going to start at the origin. We're going to go to a +6. And then we're going up to a +10. And then we're going to F here, which we're going, starting at the origin, we're going to go left to -10. And then we're going to go up to a +10. So we have all of our points here. Now what we need to do is we need to take this scale factor here, which is a scale factor of 1/2. And we need to go through and we need to multiply each one of these points by 1/2. Okay, so if I take C, I say -10 times 1/2. And then I have -6 times 1/2. -10 times 1/2. Remember when you're multiplying fractions, okay, we can write this as the whole number 10 over 1. And then we just multiply this straight across. And we get 10 times 1 is 10. And then 2 times 1 is 2. But then remember, fractions are division. So this would actually say 10 divided by 2, which would give us an answer of 5. And here, -10 times the +1/2, this would actually give us a -5. And then we could do the same thing with the next one, which is -6 times, oops, I'll write this as a fraction as well. So -6 over 1, remember whole numbers, we can write those over 1, times 1/2. Multiply this straight across, we get -6 over 2, which is going to give us a -3. Okay, we want to do this for every one of the points so that we know exactly where the new ordered pair is going to be of the image. So our next point is going to be at D. So we're going to say 6, +6. And I'll write this one as a fraction again. Remember, a whole number goes over 1. And then we're going to multiply this by 1/2, which would give us 6 over 2. And then fractions are division. So 6 divided by 2 would give us +3. And I'll write this down here, 6 times 1/2. And then we have a -6 times 1/2, which would give us a +3. And then the good thing is we've kind of already solved this -6 times 1/2 up here with C prime. So with the image of D, we could say that this is a -3 as well. And then down here, we did the same thing up with D. We did +6 times 1/2. So when we're solving for the image of E, we could say 6 times 1/2. That gave us +3. And then 10 times 1/2. Actually, we did that negative 10 times 1/2. So this would give us a positive 3, and then 10 over 1, because it's a whole number, times 1/2. 10 times 1 is 10 over 2. 10 divided by 2 would give us a positive 5. And then the last point that we have here is going to be for f. And so the image of f, we're going to take negative 10 times 1/2. And we're going to take a positive 10 times 1/2. We did both of these in the image of C and the image of E. So negative 10 times 1/2, negative 10 times 1 is negative 10, divided by 2 is a negative 5. And then 10 times 1 is 10, divided by 2 will be a positive 5. Okay, so remember fractions. If you're multiplying a whole number by a fraction, you can write it as a fraction, make it look a little bit friendlier so that you can just multiply across. Once we have that, then we can go through and we can graph the coordinates of our image, or our image after, in this case, since it's a fraction, it is a reduction. So we're making this smaller. So for C, we're going to start at the origin. We're going to go to negative 5 on the x-axis, and then we're going to go down to a negative 3. And then for D, we're going to start at the origin. This time we're going to the positive 3, so we're going right on the x. And then we're going to go down to a negative 3. So we've graphed this one. We have graphed this one. Now we're going to move to E, which we're going to start at the origin. We're going to go positive 3, which is to the right. And then we're going to go up to 5. And that would be E. And then we're going to do the last one, which is F. So we're going to start at the origin. This time we're going to go in the negative 5 direction. And then we're going to go up to a positive 5 here. So now we have all of our points plotted, okay? And we're going to connect this. We should get a square because that's what we started with. Remember, dilations aren't changing the shape. It's just changing the size, okay? It's not changing the shape. You shouldn't start with a triangle and end with a square. If you started with a square, you should end with a square. Another way we can check this once we have this is to see how with this side. Let's start with F to C. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's 16 units. And then this one is 1, 2, 3, 4, 5, 6, 7, 8. And this is 8. And remember, with scale factor, you would put the image over the pre-image, and that would give you the scale factor. Now we've already got the scale factor, but let's just double check and make sure. We would have 8, which is the size of our image, and we would have that over 16, which would reduce to 1/2, which was the scale factor that we started with. So this is a great way to check your answer and make sure that you graphed it correctly. A couple other ways you can check it: make sure that you have the same shape. Make sure that if you have a fraction, that your image is getting smaller and not larger. And the other way around as well, make sure that if you have a whole number, that your image is getting bigger and not smaller. Let's look at another example of this. So we'll move to this next one. We have the image of triangle STU. ST and U. So we just looked at an example of a triangle that was reduced in size. So now we're going to look at another triangle, but the scale factor is different. Now we're looking at a scale factor of 1/4. So we have to take each one of these points of this triangle STU, and we need to figure out what are the coordinates of the pre-image. So S, we're going to start at 0, and we're going to go left on the x-axis, 1, 2, 3, -4. And then from there, we're going to go down on the y-axis, 1, 2, 3, 4, 5, 6, 7, 8. So this would be a -8. Our next point is going to be at T. So we're going to start at the origin here. We're going to go to the right. 1, 2, 3, 4, 5, 6, 7, 8. So +8. And then we're going down 1, 2, 3, 4, 5, 6, 7, -8. And then our last point of this triangle, we're looking at point U. So we're going to start at the origin. We're going to go to the left this time. 1, 2, 3, -4. And then we're going to go up 1, 2, 3, 4, 5, 6, 7, and +8. Once we have all of our coordinates, then we can look at the scale factor. We can multiply each one of those points by the scale factor. So S, we're going to say -4 times 1/4. And then we have -8 times 1/4. And remember, with these whole numbers, we can actually write these as fractions. So -4, I'm going to write that over 1, and -8, I'm going to write that over 1 as well. So -4 times 1 would be a -4, and a 1 times 4 would be a +4. This is going to give us an answer of -1. And then -8 times 1 is -8. 4 times 1 is 4, so we would have -8 over 4, which would give us a -2. And this is for the image of S. And then the image of T, we're going to do the same thing, 8 times 1/4, and then -8 times 1/4. And we can write these whole numbers as fractions, make it a little bit friendlier to solve. And then we have -8, or I'm sorry, +8 would give us an 8, and 1 times 4 is 4. So then we divide. Remember, fractions are division, so 8 divided by 4 is a +2. And then -8 times 1 is a -8. 4 times 1 is 4, so this would give us a -2. And then the last one that we have is going to be the image of U. So U, -4 times 1/4, and then +8 times 1/4. We're going to make these both fractions, both of these whole numbers fractions, and then we're going to multiply across. So -4 times 1 is -4. 1 times 4 is 4. Remember division. -4 divided by a +4 would give us a -1. And then 8 times 1 is 8. 4 times 1 is 4. So 8 divided by 4 would give us a +2. So now we have all of the points of our image, and so we can go through and we can graph this. So we'll start with S. So S is at -1 and then -2. So we're going to start at the origin. We're going to go over left to -1. We're going to go down to a -2. And this is going to be S. Then we're going to keep moving. We're going to go to T. We're going to start at the origin. Now we're going to +2. So we're going right. We're going to go down to a -2. And then our last point is going to be at U, which is going to be, we're going to start at the origin. We're going left to -1, and now we're going to go up to a +2. So once I've graphed all of my points, now I can connect these points, and I will end up with the same triangle as we started with. The only thing now is that it is much smaller because we did reduce it by a scale factor of 1/4. And remember, we can go through, we can check our answer. We'll look at this side US. So this image is 1, 2, 3. This is 4 units. And then the pre-image is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so remember, our image goes over our pre-image, which is going to be 4/16, and then I can reduce this. I can divide both the numerator and the denominator by 4, and this would give me a scale factor of 1/4. So it does show that this is the scale factor from once we completed the reduction of this pre-image of this triangle STU. Let's look at another example. Now we have triangle STU again, but now we have a dilation of a scale factor of 2. So we want to go through, and just like we've done in all of the other examples, we want to find out where our coordinates are of the pre-image first. So let's start with S. So S, we're going to start at the origin. We're going to go over to a -5, which is left on the x-axis. And then we're going to go up to a +5 on the y-axis. And then T over here, we're going to start at the origin. We're going to go to the right to a +5 on the x-axis, and then we're going to go up to a +5 on the x-axis. And then U here, we'll start at the origin again, and we're going to go to a -5, and then we're going to go up to a +1. And now we want to look at this scale factor, and we want to see, okay, I have a scale factor of 2. So remember, if you have a whole number, we're going to make it bigger. And if you have a fraction, that's where we're going to make it smaller, okay? And so in this case, we do have a whole number, so we are enlarging the shape. We're going to have a bigger shape of the image. And so we need to go through each of these ordered pairs and multiply them, -5 times 2 and +5 times 2, which would give us -5 times the +2. The signs are different, so the answer is negative, and 5 times 2 is 10. And then +5 times +2 would give us a +10. And then T, we're going to do the same thing, 5 times 2 and 5 times 2, which would give us a new point of 10 and 10. And then we have U, which is going to be -5 times 2 and then 1 times 2, which would be a -10 and a 2. So now I can go through, I have all of my coordinates of the image. So I want to go through and I want to plot these points. So S is going to be at -10. We're going to start at the origin. We're going left to -10 on the x-axis, and then we're going to go up to a +10 on the y. This is S. And then T, we're going to start at the origin. This time we're going to go right. It is a +10, so we're going right on the x-axis and going up to a +10. And then our last point here is going to be at U, which we're going to start at the origin. We're going left this time for -10, and then we're going to go up to a +2. And so I have all of my points, so I'm going to connect these here. Now, normally we see the shape kind of inside of the other shape, but in this case with the enlargement of 2, it did kind of move it a little bit, but the important thing to remember is that it is the same shape. It is just bigger, and we can always check our side. And so if we go to the pre-image, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this side is 10. Remember, it's our image over our pre-image. We're checking the scale factor, make sure it's correct. And then this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. This side is 20. So our image was a length of 20, and then our pre-image was a length of 10. So if we divide 20 divided by 10, we get a scale factor of 2, just like we had in the question.